All right, class. So here's the recording for the test 6 sections. The test version I'm using begins with question 1, and I believe they're giving you sine x over cosine x plus cosine x over sine x. And the first thing you need to consider is you need a common denominator. So multiply the sine x up here, cosine x over here. So you get sine squared x plus cosine squared x. And all of this is over cosine x sine x. If you remember the identity, Pythagorean identity right here, this is equal to 1. So you really have 1 over cosine x times 1 over sine x, which can be scrambled. Obviously, I could have 1 sine x, cosine x, doesn't matter. Your final answer for this should end up being, depending on the order in which you presented these, could be, in this case, I believe it should be the inverse identity or reciprocal identity, excuse me. So reciprocal identity would be obviously secant x cosecant x. Like I said, you could reverse them, however. All right, so that's pretty simple, I would assume. I'm just trying to make sure I have the right tests in front of me, so bear with me of scrambling with papers. I think I looked before I started. And so, yeah, this should be answer choice A. I had the wrong test. That's why I kind of freaked out. I'm like, what is this? Okay, that makes sense. All right. A second test or second question. It starts you with sine squared x plus tan squared x plus cosine squared x. And this is equal to, obviously, some identity. So if you look here, again, Pythagorean theorem, the identity, you end up with 1 plus the tan squared x. And as you know, tan squared x is equal to secant squared x. So you need to know those identities. This answer choice should have been B. So you needed to know the Pythagorean identity, and there's a plus here, by the way. I, like a dummy, forgot to put it. There you go. Okay, again, it's the Pythagorean identity. This is where you get the 1. You just drop the tan squared x, and its identity is secant squared x. All right, question number 3. On question number 3, they start you with cotan of x plus 1 times, again, cotan x plus 1 again, minus cosecant squared x. And we're trying, and all of this, I'm sorry, all of this is divided by cotan x. So what we do know is after I factor this, right? So this times this, inner, outer, of course, inner and outer combined, and then the last term, basically a FOIL, right? When we do the math, we end up with cotan squared x plus 2 cotan x plus 1. And this is minus cosecant squared x. And yes, all of this or a cotan of x. So if I take this part of the function, this part of the function, if you notice, I end up with great, so let's give it a minute to come back. Oh my God, Lorel, this is not right. No reason for this to happen. So I end up with, once again, we're at cotan squared x plus 1 as an identity. And we know that this identity, so I'm just going to write this down for a moment. So and for the record, if you hear the dog in the background driving me absolutely insane, she's perfectly fine, for the record. Okay, so this reduces to cosecant. All of this reduces to the identity cosecant x plus 2 cotan x minus cosecant squared x, and again, all of this over cotan. So if you remember, this is cosecant squared as well. If you remember the identity, and this is what I want to bring to your attention, is that cosecant squared theta minus cotan squared theta equals 1. So if I manipulate it, I'll get cosecant squared theta is equal to 1 plus cotan, I believe it's cotan theta, cotan squared theta. All right. So that's where I'm generating this value from. All right, and obviously this can be cotan squared theta plus 1 as well. So if I reduce this, notice that I end up with a cancellation. So this will cancel with this, right? And if I divide this into each other, because that's cotan x, I'm left with 2. And that is your answer choice, which is answer choice D. All right. Let's take a look at question number 4. All right. In question number 4, we're given the question where we have sine x minus cosine x, and all of this is over sine x. And we're adding cosine x minus sine x, and all of this over cosine x. So if we split this up with, so you end up with sine x over sine x minus cosine x over sine x, and all of this plus cosine x over cosine x minus sine x over cosine x. You'll end up with 1 plus, or I'm sorry, 1 minus cotan x plus 1 minus tan x. So if I add the twos together, I end up with 2 minus cotan x minus tan x. If I rewrite this or re-express it so that I have 2 minus cosine x over sine x minus sine x over cosine x. And yes, I'm going to cross multiply yet again, cross multiply. You're going to get 2 minus cosine squared x minus sine squared x. And all of this is going to be over sine x cosine x. So working this out, remember that these guys will cancel each other out and these guys will simplify out as well. So you end up with 2 minus 1 over sine x times 1 over cosine x. This yields you, when you're done, because remember you're splitting this up with this denominator in both locations, so they're both here, right? So this is how you end up with 2 minus secant x cosecant x. All right. Question number 5. Question number 5, you have several identities to think about. So let me start you with the question where you have tan squared of 2x plus cosine squared of 2x. Think of that as just an angle, doesn't matter. Plus sine squared of 2x. And we're proving that this is equal to secant squared of 2x. So going back to your basics, you know that tan squared 2x plus 1 is equal to secant squared theta minus 1 plus 1. And that is equal to secant squared theta. And theta can be the 2x, it doesn't matter. What I need you to remember in this case, that your answer choice obviously is secant squared of the 2x, which is your final answer. And this comes from remembering a couple of identities where one of them is simply that secant squared theta is equal to tan squared theta. And you also need to remember that this is the plus 1. This value here, I know it's strange. That's where we're getting that plus 1. Okay, so this is actually a very simple question. You just have to play with the identity given to you. Okay, I'm gonna pause the video here and I'll resume in a minute.